So in the previous video, I worked out the empirical formula of vitamin C, given the percentage composition by mass, and we did our various different calculations. Step 1 was to divide the percentage by the atomic mass for each element, then to divide by the smallest product. Once we get the answer to that, we divide all of them by the smallest answer. Then when we get the product of that, then we get the ratio of elements. If we end up with a fraction, such as a half or a third, then we need to multiply all of the ratio by a factor of 2 or 3 to get rid of the fraction so that we've got a whole number ratio. And so we ended up with the empirical formula for vitamin C of C3H4O3. Now in this next step I'm going to show how we're going to calculate what the molecular formula is. Now the empirical formula is the lowest ratio. The molecular formula is going to be some multiple of the empirical formula. So we're going to have to multiply the empirical formula by some whole number, being n, so that we can actually get the molecular formula. And it might be that we have to multiply by 2, in which case we'll have C6H8O6. It might be that we have to multiply by 5 and we get C15H20O15. So the question is, what is this multiplier? How do we work out the multiplier? Well, you will be given another piece of data and you'll be given the molecular mass of the vitamin C. So we're told in the data that the molecular mass of vitamin C is 176 grams per mole. Now the vitamin C molecule is some multiple of the empirical formula. To work out N, the multiplier, it's going to be the mass of the actual molecule divided by the mass of the empirical formula. When you work out this division, this ratio, it will tell you how much bigger, how many times bigger the molecular molecule is than the empirical molecule. If we were to work out the mass of the empirical formula, we would have 3 12s from the carbon, which is 36. We would have 4 1s from the hydrogen, which is 4, and we would have 3 16s, which is 48. If we add that up, we get 88. Is that right? 10, 18, carry the 1, yes, 88 grams per mole. So, we're told that the mass of the molecule is 176. We're told that the empirical formula is 88. If we do that calculation, and let me pop it into my calculator, 176 divided by 88, we get 2. Generally, you can see that. So this means that the molecular formula is the empirical formula times 2. So the molecular formula is going to be C6H8O6. And that is our final answer. Very easy to do. This last step is very, very easy to do. Often you can see just by looking at it that the molecular formula is about twice as big or 3 times as big, and therefore my multiplier is quite obvious. Could be that you need to do a bit of rounding here because your multiplier is only ever going to be a whole number, and then we end up with our molecular formula. So empirical formula, the lowest possible ratio. Then by looking at the ratio of the molecular mass to the empirical mass, we can work out the multiplier, and then we can then simply multiply the empirical formula by that multiplier and come up with the molecular formula. Easy peasy, lemon squeezies. If you have any issues or any problems, just jump online, send me a message. Happy to talk you through it and work through the examples that I give you, and once you've done that you would have pretty much nailed it. So that's pretty much week 2 of term 2. Good luck for this week's work, and on Thursday we will have our class teams meeting when I want all of you to check in and make sure that you're on board with this. If you need any clarification, we can have a optional Teams meeting on the Monday. All the best for now. God bless you all. Look forward to catching up with you when we're back at school. Take it easy.